Without an algorithm, then you wouldn't be able to make your morning cup of coffee. And if you didn't have your morning cup of coffee, you may end up laying on the floor, curled up in a ball, wondering what you could have done to anger the gods in such a way. And that's not good. So this video is based on a suggestion from Paul Seal from codeshare.co.uk. If you'd like to suggest a topic, then get in touch over Twitter at podcasterj. Check the description below, there'll be a link. Or indeed leave a comment. And thank you to Paul for the suggestion. So today's topic is, what is an algorithm? And an algorithm is quite literally just a set of instructions. It comes from this fella who's on screen, the 9th century Persian polymath Muhammad ibn Musa al-Khawazimi. I apologize profusely because I've just butchered that pronunciation, so I apologize. There it is right there. The reason that it comes from that fella's name is because he was essentially, a polymath is someone who just learns all the things, right? And it comes from the Latinization of his name, which comes out slightly different. So if you're at all interested, I'll put all of the links to all of these Wikipedia pages below. The Latinized version of his surname comes out as algorithmi, which is where we get that from. But we know algorithm from its use in the so-called decision problem, or the halting problem. Let me just switch to this one. So the halting problem is all about figuring out when an algorithm or a process may end. And if you don't know about that, then I would definitely recommend looking into that. That's a computer science and mathematical problem. It's all about how do we know when a problem will end, when a set of steps will end. And if we can figure out if a set of instructions does have an end point, then we know whether there is enough time in the universe to be able to complete it. And this was what was used by Alan Turing when he created his Turing Machines, which is just over here. I've probably done that wrong, I've got that video reversed, but wherever it is on screen, go have a look. Alan Turing came up with the idea of a universal Turing machine based on the work that Alonzo Church did in creating functions. Now, we use functions these days in functional programming in the way that Alonzo Church described them, but Alan Turing took that idea and came up with this idea of a universal Turing machine. Now, the universal Turing machine is a huge topic. I'll sometimes refer to them as UTMs, but you can imagine that it is essentially a proto-computer. It's got, for want of a better phrase, a tape, because these things were postulated in the 20s and 30s when we used tape. So you have this row of instructions, and each step in the instructions, each cell in that tape, imagine it's like a film cell, right? So you've got a film cell that says either move left or move right. And it may say move left by 2 or move right by 2, and it also may say store this number in memory, or it may also say load the number from memory and add 2 to it. And so the idea is that the tape would start at the beginning and it would say jump forward 2 steps and jump forward 2 steps, and then there it might say add 2 or store the number 2 in memory and go back 1 step. So it stores the number 2 in memory and goes back 1 step, and then it says add 1 to the number in memory and go forward 3 steps. So it takes 2, adds 1 to it and gets 3, and then moves forward 1, 2, 3 steps, and that would have the next instruction. That's essentially what a Turing machine is. It has a read and a write head, so it can read the value of the cell it's looking at, or it can write to the cell it's looking at, and that's essentially what a Turing machine is. It is essentially, I've said essentially about 9 million times, it is a computer, right? And that's where it's Turing and von Neumann and a bunch of other people who sort of iterated on this idea brought about this idea of computers. So you have all of those wonderful folks in the 20s through to the 50s to thank for the fact that we actually have a digital computer. Side note, computers, a computer before the 50s was a person. So in the lead up to the 50s, computers that we know, like what I'm sat in front of and what you're probably watching this on, regardless of whether that's a desktop, a laptop, or a phone, or a tablet, or any of those things, they are all computers, just in different form factors. Bash the microphone there. In different form factors, based on what their primary usage is. But regardless of which computer you're using, you have Alonzo Church and Alan Turing and John von Neumann to thank for the ability to hold a thing in your hand. But like I said, before they came along, a computer was a person who computed the result of a certain set of instructions. These instructions may be tabulating weather forecasts, figuring out sine and cosine values, figuring out decimal points for, say, pi, or just doing scientific calculations. A computer would be someone who would sit with a table of sine, cosine, and tangent rules, perhaps a slide rule, and perhaps lots of other different mechanical devices to help them figure out the solution to a problem, and be given a problem, and it was their job to actually solve it. So there you go. But anyway, none of that is about algorithms, right? Algorithms are essentially just, I said essentially again, a list of instructions that you describe to a computer. You take this list, you give it to a computer, and the computer or the person or whatever it is, because it doesn't have to be a computer, will follow those instructions until that list of instructions is completed and whatever process has finished, right? A lot of YouTubers talk about the algorithm when figuring out what kind of content to put out there for people to view. They talk about it as if it's some kind of magical incantation. You know, you sort of wave your hands vaguely in the air and dance around in your living room and say some magic words, and somehow the algorithm will pick the video that you've just produced and show that to people. But essentially, I said essentially again, I'm going to have to stop saying essentially, because now I've got semantic satiation. Check that out, definitely Google that. But now the YouTube algorithm is just a simple set of instructions that describe which videos to show in the sidebar or to suggest in the player when the video has finished. Right? That's all it is. It's not doing anything well, it will be doing things that are clever, but when you boil it down, it's just a list of instructions for the YouTube server to run before it shows you the video to suggest the next video. And that's all it is. It's not really that much complicated than that. Not that much more complicated than that. There we go. So as an example, because I'm an examples person, let's talk about making a cup of coffee, right? Because without an algorithm for it, you wouldn't be able to make your cup of coffee. And without your morning cup of coffee, you may end up laying curled up in a ball on the floor, cursing the gods and wondering what it is that you could have done to upset them so much to put you in this position. And that's not good, is it? Right? So I am going to talk about my personal coffee algorithm, and I've got it written down in front of me, so you'll have to bear with me whilst I read it off of the list, right? Everyone's personal coffee algorithm is different, and obviously I'm using algorithm here, but this is maybe a recipe. So if you're making a cake, you're following a recipe, that's the cake algorithm. The chocolate cake algorithm will be different to a lemon cake algorithm. The chocolate cookies algorithm will be different to, say, pecan cookies algorithm, right? But here is my personal algorithm for making a cup of coffee, and I'm going to read it off of this little screen I have just in front of me, okay? So you have to bear with me. So step 1, find a clean mug. If a clean mug can't be found, load and run the clean and X algorithm and replace X with a mug. Find the instant coffee in the cupboard. I don't usually drink instant coffee, but I've used instant coffee in this algorithm example just to make it simpler. Otherwise I'm talking about turning the coffee machine in and filling all the filters. Anyway, yeah, find the instant coffee in the cupboard. If instant coffee cannot be found, run the buy instant coffee algorithm instead and stop, right? Find a clean teaspoon, right? If you can't find a clean teaspoon, then find a clean X algorithm, load that in and replace X with teaspoon. We now have a cup, a teaspoon, and some instant coffee in a jar, right? Empty the kettle. Personal opinion, never reboil water, but personal opinion, right? So you empty the kettle, presumably into the sink or some other receptacle, just in case there's something else in there. Fill the kettle with water from the tap up to its halfway point. I had to come up with a specific point to stop filling the kettle up and not be vague. Fill it up with enough water to fill the cup. Fill it up to the halfway point, right? Place the kettle back on it to its power plate, if it has a power plate, or somehow connect it back to its power source and switch it on. While the water in the kettle is not boiled, check Reddit on your phone, or check Facebook on your phone, or give Jamie a thumbs up and a like, or whatever it is that the YouTubers want you to do. Once the kettle has boiled, take a couple of teaspoons, I usually only put one, but take 1 teaspoon of instant coffee, put it into the cup. Now pour boiling water into the cup, enough to fill it to about 80% full. Begin to gently stir the coffee water mixture. Continue stirring for at least 30 seconds. Everyone's different. Remove the teaspoon, wait for it to cool down, enjoy coffee. That essentially is a coffee algorithm, my personal coffee algorithm. Everyone has different ones, but that's essentially it. Admittedly, this coffee algorithm is extremely detailed, but you kind of need to cover every possible corner case, right? And I didn't cover every possible corner case. What if I'm not in the house? What if find a clean mug means going to the shop because I don't have any mugs, right? You have to, when you're crafting an algorithm, think of every single possible corner case, every possible outcome of it. And this is a perfect example of this is the classroom challenge PB&J video, which should be showing on screen right now, which is a wonderful, brilliant example of being really super specific. And this is by Josh Darnett. And I would recommend that anyone who works in development or works alongside developers or works alongside anyone in the tech space definitely checks out this video, because it is a perfect example of just how specific you have to be when dealing with any kind of developer or tech worker. So pro tip from this video is go watch that video, right? And I promise you it will improve your algorithm writing skills, even though you're sitting there going, but it's a bunch of kids teaching their dad how to make a peanut butter and jelly sandwich, or peanut butter and jam sandwich if you're not from the United States of America and surrounding areas. But I promise you, watching that video will help you, either if you're a dev or someone who works with devs, to get a better understanding of exactly how an algorithm works. It is a perfect example. But anyway, that's it, right? That's just exactly what an algorithm is. So to wrap up, an algorithm is just a set of detailed steps that you take to finish or complete a task. Typically, algorithms are used to describe something that maybe a computer will do with some kind of input data, such as the YouTube algorithm, but it can be any list of instructions at all. It doesn't have to be something for the computer to do. If you have to give someone a list of instructions to do something, you've given them an algorithm, right? Typically, we'll express algorithms with mathematical formulae and mathematical symbols if you're in a mathematical or computer science arena. If you're talking about bubble sort, there will be some mathematical symbols involved to discuss bubble sort. But if you're talking to developers, not computer scientists, then you'll likely either have pseudocode or some kind of a UML diagram, or some kind of even just straight code, or just a list like a paragraph or a set of bullet points that describe how to do bubble sort. But that's essentially it. That is my description of what an algorithm is. That's about it really, but thank you very much for watching, and I hope you enjoyed it. If you did, do the whole like and subscribe, and I'm not that really bothered if you don't like and subscribe. It would be great if you did, but it's not the end of the world for me. I'm just putting this information out there for people to view, and if it's interesting or whatever, let me know. Maybe leave me a little comment. Reach out to me if you'd like me to make a video on a specific subject. As I said at the top of the episode, at podcasterj, or leave a comment below and I'll see what I can do, okay? Again, my thanks go out to Paul from codeshare.co.uk for coming up with this topic, and I will see you again another time.